What's up? How's it going, everybody? Thanks for coming. It's really early on the first day of the conference, so I'm really impressed. We got a full room here. And how many people have one of these so far? Oh, I see a few in the back. Well, at the end of this, whoever has the best question gets one of our Mr. Enclave plushies. And this has to do with the talk, really. Mr. Enclave is an homage to TEs overall and how we actually secure switchboard data. So anyone's been building on Solana for a few years, you've probably used Switchboard at one time or another. Who here has known or built a switchboard before? Very good, wonderful. So Switchboard has been around since April 2021. We've been building for a very long time. We've done the ups and downs of Solana for the scheduler. We've been through the cranking of transactions. We've switched models a few times and learning how developers really want to use Solana and use oracles. But overall, through that period since 2021, we've updated over 2 billion data points of price services for Solana, and that's only counting Solana so far. So a little bit about me. My name is Doctorblocks. I've been CTO and founder of Switchboard. Before this, I actually got a degree in computer security. I actually taught a few courses at University of Michigan, and I know there's actually a few people at the Solana Foundation itself that went there too. And after that, I was a lead on App Engine working on networking security. And through this whole journey, I've come to really appreciate at scale how you actually work on networking, how you can manage load and distribution for highly volatile or high fidelity data, I should say. So why Switchboard from that background? Well, from this entire history, I've really gotten into how networks work, what makes things so efficient, and I actually came across my partner who actually worked at Circle's trading desk, who know how to make markets efficient. So it was actually a very good interaction for building a base layer of Solana when things were just starting out. And deploying in April 2021, we were there really from like the second hackathon onwards, and we've been around for a lot of the growth it's seen today. So you can see ChatGPT has blessed us with this little image of Mr. Enclave defending Tully and Raj from the FTX monsters and keeping everyone's fun safe. It's really, really beautiful that I made that myself, I could say. So our goals are building a more secure pricing service data layer for Solana. And when you think about what all DeFi is built on, it is the broadest data layer possible for this pricing information. How do you get the most accurate, most competitive pricing possible? And what challenges actually come with that? The challenges are how do you actually source this pricing data while being fair and secure? And our solution overall is actually using our confidential container framework that we've actually developed for Switchboard. So from our history, we've done a V1 of Switchboard, and that was actually using protobufs because I was a Google engineer and I thought that'd be most efficient over the wire. Then I realized how inefficient that would actually be for all the serialization services and compute and cost for users. So then we became much more efficient with our data layout, and that was our V2, which we ran until mid last year. And our V3 is our on-demand version, where we actually have a whole pricing service where when you request an update, only then do we fetch the sources and let you bring it back on chain. So no feed cranking is needed. And this actually lets us go extremely quick. They have extremely high fidelity with our pricing. Some of our users on Solana, you might recognize a few of these here. This is an incomplete list. This is actually a little bit old. But we've had very, very good saturation in the Solana market so far for actually who's use these pricing services and who's found value in being able to build your own data feeds and the speed that we can offer. So what is Switchboard OnDemand that I'm talking about is so much more efficient? So when you think about oracles, a lot of them actually have their own data layer set up. They actually all have oracles that will agree on supporting a set of price feeds. They all push these prices to a data layer, and then anyone can go and read these whenever they like. When we're actually building the fastest data service possible, we notice a very obvious middleman. Why do you have that data layer in the middle when people want to get these prices constantly, or like especially when they want them? And how you can make this as scalable as possible, because Switchboard really is the only Oracle building platform out there. You can make your own data feeds, which makes it so transparent and powerful. So what we did is we actually took that data layer out, and only when people request information do the oracles go to the work to fetch them from the sources that the users requested. So it lets you be extremely scalable because data feeds are only supported on the network as long as people are requesting them. And with that, we've already supported over 6,000 unique data feeds for people, which is 6 times the closest competitor. Some performance metrics, because we can do this, 400 milliseconds is actually a little bit slower than the optimization we made recently. It's closer to 350 milliseconds for some data feed updates. Also, this, of course, does depend on proximity to sources and where you are geographically. But this is, if you actually think about the speed of light around the world, it's 181 milliseconds. It's pretty good relative to the actual true lowest bound that you could actually reach. And the uptime becomes a lot easier because oracles don't have to push the transactions on the chains themselves. So it's easily turns into the question of managing SLA services for essentially a Web 2 style business where you can actually collect the metrics from all the partners that you have running oracles. So what's the big picture of what Switchboard is? We've done over 2 billion price updates just from those different models up to date. We secure over $5 billion, and we have actually now just over 1 million unique users that have signed for Switchboard data before. The direct architecture is you want to actually use a price feed for, let's say, a borrow-lend protocol, and you need to price your collateral. You have a market, let's say on Save protocol, that you want to update the prices for because you want to deposit or withdraw. You actually request a price update from Switchboard on deposit, and they will give you back a transaction that actually has the signatures in it. You can then submit that with your deposit, so you have the freshest prices possible, and you can get your actual loaned credit out, while the collateral was priced as strictly as possible relative to when you actually took out the deposit. Overall, it's very, very useful when the data can fit in the user's transaction rather than the protocol needing to crank it constantly. Then you actually can socialize the cost to the actual users rather than a protocol having to be over-endowed with all the pricing that it takes to, say, support a perpetuals market. So being very cost efficient, being very fast, and being very small, especially in a Solana transaction, is very important. So when you look at the benchmarks for actual speed, you have some services, 2 ways to think about latency. There's latency between your request and getting the data back, and then there's the staleness of the data itself. When you think about the latency of the request and back, we actually take that time with the staleness of the data because it's all on demand. Some other services can do it sub-second, so, but it depends on how often they update their state layer, which is a lot higher if you actually look at the data. So I caution you, in the world of oracles, know what types of markets you're supporting or that you're building. Because I think data that's 30 seconds old might be fine for a lending market, but that's not fine for perpetuals or Oracle AMMs for that matter. So then we're coming to things that are developing at Switchboard. So we've talked about the Switch token. We've had the white paper out since the beginning of this year. What does it actually do? So this is actually going to provide a service to people using the Switchboard protocol. As I mentioned before, Switchboard is an on-demand request-based service. That means there is a capacity for the entire network. And totally actually very accurately said one time, the whole idea of tokenomics, at least in L1s, is to reduce spam. That's really the goal here. So when you think about Switch, you can actually stake Switch and actually hold a wallet that signs requests to this web service that can give you different tiers of requests that you make per second, per minute, etc. And especially when you're a user, you don't really have to do too much of this, but if you're actually running advanced strategies, this really does come in handy. Other than that, we actually have the service staked to allow governance. So we're going to be plugged in with Solana Realms, and all of our base layer for governance is home on Solana, because this has been our home since we started, although we're on 10 or so different chains so far. But essentially, in the GDOS NCN, users can actually stake Switch to an oracle. That would actually weight which oracles get more requests, which means more payouts for them. And people are obviously more incentivized to pay out the faster oracles, because the speed of the request is almost everything that the user really cares when they're representing what the requests are getting back. And the other side of that is staking to your wallet, so you can make more requests to the network. So really, where do the confidential containers come in? And just raise your hands, do people know what TEs are? It's a very, we got a really good turnout here, actually. That's fantastic. So just for those who didn't raise their hand, TEs are a trusted execution environment. It's actually a hardware layer that you can prove what's been running on the chip. So let's say I'm running a web service in a TE, and I want to prove to some Joe Schmo that I'm actually an oracle. I can make a request to oracle.com/request a quote. And what this quote will do is it gives it back to the user, and it's actually signed by a chain, signed by the chip manufacturer itself. And then you can actually verify, okay, this is actually the checksum of the data that's the person on its side. This is the signature of their actual VM. And this is the certificate chain proving that this data is from this machine and is running confidentially. So you can get that back from this machine. You can check with AMD that this is actually the Oracle code because it's been signed by the chip. And then you can verify the data was actually produced by this code. So in this way, you can actually prove that some output was created by a VM, or a container image is what I'm getting to. Now, what we've actually seen historically is that running VMs is longer. It's not as useful or dev-friendly as Docker. Docker is extremely dev-friendly. You can spin up a new, what seems like a VM in a few seconds. So can we actually abstract away that VM part and just make TEs look like a Docker container for people? So that's really the goal, and actually what we've built already with our oracles. And we actually want to broadcast this out to be a utility for other people building these new wave of products. When you think about LLMs or AI, how do you actually verify an output is from an LLM? Let's say, do you actually do something on chain that you can actually do this? Currently, there's not a great way to actually accomplish this. So our solution is to actually run any of those types of products inside a TE that we've Dockerized for you. You can actually broadcast a quote and then offer your source code for your VM and compare the two. And as long as they match, we've just proven that you're running your LLM inside a TE. And what's the most useful part of this is what I actually skipped in the beginning, is that inside of our framework, we actually generate a key pair inside of the enclave, proving that this is the signing key representing your code. And anything happening on chain, if it's signed by that key, we've already proved that it's your AI model, it's your Oracle, etc. So what are we calling this? It's a really fun name, Switchboard Attestation Inference Layer. So actually, when you attest to TEs, there's a whole attesting framework. And we added inference because it makes it sound really cool, doesn't it? I really like the sailboat, so it's very fun. But we actually want to make this secured architecture that anyone can really simply just make a Docker container and say, I'm ready to go, plug in our SDK, and boom, done. And we are actually coming out with demos very soon for this. We've just completed our fork of the confidential container runtime, which we might be hosting at KubeCon as well. And we actually have support from the AMD team working on this as well, which is very appreciative to make this more generalized and simple for the blockchain space. So that's my presentation. Thank you very much for listening. I really appreciate the great turnout.